Previously, we looked at how we added paths to our terrain and imported them into Unreal, setting them up with our texture arrays and ID map to produce the end result that we're looking at here. Today we're going to be looking at how we added foliage to our terrain. We're going to be adding 3 types of foliage: deciduous woodlands, coniferous woodlands higher up on the slopes, and finally some sort of mountain ashes that are peppering the hillsides there. We're going to be looking at the way that we set this up, using specific masks crafted for each type of foliage, and how those drove initially some scatters and then some advecting of points to add interest and detail to the masks, leading to the end result that we imported into Unreal. Okay, so we're going to dive straight in, and we're going to pick up where we left off here after this sort of work we did on the trails. And first thing we're going to do is going to make a nice bit of space there we're going to work in like usual. And I'm actually going to go ahead and put down a new subnetwork directly here. So this subnetwork is going to contain all the work relating to the woodland. So I'm going to call that the woodland. All right, so we're going to feed in the output of the terrain there with the paths. We're also going to feed in the output of this kind of work on the ID map. So we have all of our materials available to us to work with. So I'm going to throw down a quick little null, call that one ID map. Make sure that's all hooked up. And then I'm going to make an object merge, keep things a little bit more organized. Alt \, wire that in there. Okay, plug that into the second input. So in our left input, we have our terrain textured. The texture is not really going to help us out with the processes, but it's nice for visualization. But more importantly, we've modified the height with all of our previous work. We want to have the true height of the terrain, whereas the ID map doesn't have the modifications to our height, but it does contain a lot of information about what surface materials are where, which is going to be useful to drive the distribution of the woodland. So we're going to work through this a little bit iteratively, and we're going to start off by basically doing a simple scatter and then trying to get that into Unreal immediately. So to begin with, we're just going to put down a height field visualize here because we want to be able to visualize the contents of our masking processes. So we're going to turn off no material preview and use default tinting. So now we can see our masks. And right out of the gate, we're just going to make a little bit of a height field mask by feature. And we're going to do a little height field masking just not by the slope, but instead we're going to do it by the height. I'm going to hit compute range, and I'm going to hit hill. I'm going to go to this little cogwheel and choose the hill preset. And I'm just going to isolate a very thin band of our terrain here, which we're going to use to do our initial scatter on. So the next step is going to be the scatter process. And we're just going to take the left input there and the right input there. And then we're going to see that we get straight away, it's going to take a minute to cook, a load of points spawned on that region of the terrain. Now that's a little bit more dense than I need, so I'm going to go up in the height field scatter to near the top, and I'm just going to set the coverage to 0.1. Okay, that's a little bit better. And now I'm going to modify the output of the height field scatter to not keep the incoming terrain there. So we're just looking at the scattered points, and we can still see it's pretty dense. So we're going to go and lower that down even further. There we go, just an initial little test scatter. Okay, so the next thing we're going to do is we're going to visualize what that looks like in Houdini if we were to just copy some meshes to those points, and not trees, but just a little cube sort of bounding box to see what we're working with. So I'm going to create a null. It's the output of the scatter. I'm going to call this out pine, or out, let's go out tree scatter. There we go. And then I'm going to make an object merge for the out tree scatter. The reason I'm doing this is just to sort of preempt some work we're going to do later. And we're also going to put down another null here. We're going to wire all of these into the null. I'm going to call this null in height field. Okay. And you might have guessed it, we're going to make another object merge, which we're going to wire the in height field to. So now we have our height field, and we have our out scatter here, kind of separated away from the logic we're doing. This is going to be our little preview section. We're going to merge these two again, but rather than leaving it at that and just previewing the scattered points, we're going to use a copy to points like so, and we're going to place that there and then wire the object merge with the scatter. I'm going to drag that onto the copy to points, and then we're just going to make a little cube, wire that in to the left input. So we are getting some cubes, but they're too small to see. So I'm just going to set the height to about 15 meters, which is a pretty reasonable size for a tree. And we're going to set the size to maybe 5 by 5 on the sides. And there we have a visualization of our tree scatter that's going to come. And we can see that by default, the height field scatter is doing some kind of orienting towards the terrain. And we're not going to worry about the height field scatter's orientation settings. We're going to do our own in a little bit with our own Pegasus node. So we're going to go ahead and turn off match normals. We're going to go ahead and turn off match direction. And we're also going to go ahead and turn off relax points because that's going to make the scatter happen more quickly. And it's not really necessary. So you could play around with this and see what you make the most of these settings. But for the purposes of this demo, we're just going to leave it on a pretty basic mode of scattering. Okay, so I can wire the output there into the output of that tree scatter as well. So we now have our little preview section, which I'm going to bound with Shift-O. I'm going to call this preview. And then this is our first scatter that we're going to be worrying about. So I'm going to move this down a little bit more, make a little bit more space, like so. Yep, keep that down there. And we want to get this into Unreal as soon as possible. So to do that, we're going to need to put down the Pegasus Unreal Instances node. And what this node does is it essentially allows us to configure a bunch of attributes or settings on the points. That means when this gets read into Unreal, it's going to load the meshes in as foliage onto the terrain correctly. So you can jump inside there and have a look if you want to know what's going on under the hood. But all that we need to worry about here is this kind of one input box, which tells you how to use it. So we need to go to Unreal, make a selection of assets. I'm going to right click them all and hit copy reference. And then we're going to paste the references in here. And that reference is going to look like this. Okay, so I'm going to jump back over to Unreal. And we need to navigate into Content, Pegasus, Meshes, Foliage, Trees. And I'm going to go for the pine trees first of all. So we're going to follow these instructions and shift select these three meshes, right click and copy the references. I'm going to jump back into Houdini. We're just going to go ahead and paste those references in there. And that's all there is to it. So we wire that in after the height field scatter. Okay. And now we just need to get these over to Unreal. So the way that we do that is we can put down a file cache. I'm going to make it be explicit. So we can just set the cache direction manually. We're going to make it not be a time-dependent cache. And then what I'm going to do is I'm going to open the floating file chooser. I'm going to navigate to our Pegasus demo, or for you, it might be just Pegasus. Pegasus demo, source content, wherever all of your Pegasus content is installed. Pegasus, foliage. And you can see that I already did a little test scatter here, but I'm going to overwrite that. So you just call it foliage underscore pine or whatever mesh you're choosing to scatter .bgo.sc. Okay. And actually the way I like to do this to make it even clearer what's going on inside of Houdini is I like to cut the last part of the name. So everything that's not the directory, I like to type $os. Now, why would I do that? Well, if I now middle mouse click where it says geometry file, you can see that it's just using the name of the file cache itself. So I can paste the foliage underscore pine.bgo.sc there as the name of the node, and then that gets copied in automatically. And you can middle mouse click to switch between the sort of script view and the normal view. So this just helps me to sort of be very clear about what's being saved out where. So I just like to do that. And then I'm going to leave this off to the side, and I'm going to go ahead and hit save to disk. Okay. So we've saved out that point cloud with a bunch of attributes. And just to see what attributes we're getting, I'm going to right click and go to the spreadsheet. And you can see we've got the position, the normals, and orientation attribute, some scale attributes, and of course, a few Unreal specific instances that have been set by our node, including the paths. So if I actually search the attributes and filter by Unreal underscore instance, like so, there we go, and stretch that out, you can see that out of those three assets, we're getting sort of a random selection of all of those being applied to each point. Okay, great. So now if we pop over to Unreal again, we can go to the top level. And what we're going to do this time is we're going to search for BGO. And then we're going to also turn on the filter for Houdini assets. So you can hit these three lines here and go to, I think it's miscellaneous. Yep, miscellaneous filters, and turn on, tick the Houdini asset filter if you don't see it. And we can see that we have now got a Houdini import BGO. In fact, there seems to be one that came directly with the, so one second, that's interesting because I wasn't aware of that. So filters, miscellaneous filters, Houdini asset. It appears that we have a Houdini BGO import that comes with the Houdini engine content. So somewhat redundantly, I've also actually input sort of my own version of that. So you can use whichever one. I'm going to use the SOP p import BGO just in case. And I'm going to right click it and instantiate it at the origin of the world. Okay, so we don't see anything by default, but if we select it in the world outliner and scroll down through the settings, we can then set the geometry file. So of course, we're going to open that file chooser. We're going to navigate to the location where the foliage cache is. There we go. So I'm going to paste that, copy that reference over, paste that, and then select foliage.pine.bgo and hit save. And just like that, we can see that we've now imported that scatter of foliage onto our terrain. Dead simple. Okay, so this is just the raw scatter, and we can do a lot better than this. So we're going to go back to Houdini, and we're going to start sort of really sculpting and thinking about where we want these pine trees to go. And bear in mind that we have 4 tree types in the project. We have hazel, we have mountain ash, pine, and we have some birch trees, which are sort of going to work as deciduous woodland. So I think what I'm going to try and aim for is deciduous woodland sort of covering the valleys and sort of lower regions that are not too exposed. I want to have pine trees, which are on the slopes, but not, again, really, really exposed. And I also want to kind of try and get some directionality in, because often what you see in real life is that you have sort of trees that prefer one slope or one side of the slope of the mountain to the other. And then I'm going to use the mountain ash to sort of like pepper around on the hillsides. And it's sort of less of a woodland and more just sort of like scattered mountains on the trees, sort of, you know, growing in those more perilous conditions. So we're going to go back to Houdini. And first of all, we're going to do a little bit better with this initial pine scatter. Okay, so we've got that raw scatter there. And basically what I want to do is just visualize the mask that we're using. And I want to do a couple of things. First of all, I think I'm going to expand that region of the hill that the trees can spawn on ever so slightly. Okay, so we're not getting the tops of the peaks, and we're not getting the base of the valley there. So I quite like that. And now I'm going to turn off that mask by height for now, and I'm going to visualize a mask by slope instead. And we're going to try and identify the slope regions that are kind of okay for the pines to spawn on. So I'm going to go ahead and switch this mode to linear, like so. And actually, I'm going to flip that around there. So now we can see that there's a real preference towards sort of flat regions. And if I go ahead and then start dragging these sliders, we can sort of lock out the steepest slopes from being viable areas for the trees. So we're not just limiting by height anymore. We're also saying, okay, you can't really spawn trees on the steep slopes. So something like this, I think I'm quite happy with. You can sort of just play around this and art direct this to your heart's content. All right, mask by slope. And if we combine the mask by slope and the mask by height there, you can see the mask that we end up with, which is all right, but it's still a little bit bland. And also, it's kind of covering sort of indiscriminately areas that are sort of, you know, facing the sky versus areas that are like a little bit more occluded there, sort of in the sort of shadow. So let's go ahead and deal with that now. We're going to go to the mask by occlusion. Now, this can be a little bit slow to run, and we don't need much precision on our masking by occlusion. So I'm going to put the number of searches down to 4. There you go. You can see there was basically no difference, but this is going to compute a lot faster now. And I'm going to set the view distance to 500. So it's just going to slightly change the mask there. And then I'm going to play with the ramp. And what I want to do is I basically want to create quite a sharp mask that defines the difference between the kind of like these exposed areas and then the areas that are more sheltered. So in this case, red is exposed and white is more sheltered, because often trees have a preference to be in less exposed areas. So I'm going to go ahead and pull that out and sharpen that up. Okay, and now if I flip this vertically, you can see that very clearly we're getting a nice sharp mask, one of which sort of grabs occluded areas and the other one grabs those kind of more exposed areas. So you can really sort of tweak this just by dragging the ramp there and sort of getting it where you're happy with it. So I think this is quite a nice mask for the pines there. It's going to sort of cause them to creep up the sides of the hills. So we can go ahead and recombine that with the slope. Recombine that with the height. And if you feel like you're now sort of isolating too small of a region, I would just grab that height one, and you can still sort of broaden that, maybe add a couple more points and sharpen that mask up a little bit. So there we go. Okay, we're getting some nicely defined regions where we're going to be placing our pine trees. Okay. Yeah, I don't really want it creeping into the valley bottom too much, so I'm going to slide that back there because that's going to be reserved more for the deciduous trees. So that's looking pretty good. Now, last but not least, we're going to want to make sure that we're getting in that behavior I mentioned previously, which is kind of masking by a direction as well, because we often see trees favor one side of the slope, maybe where there's less sun or less wind, or more sun or more wind, depending on what species it is. So I'm going to go ahead and increase the angle spread there. All right, so now we're clearly identifying one slope as being preferable conditions. And I'm also going to go ahead and change this to hill mode. So we get nice soft fall off and we can kind of play around with that fall off there. The aggressiveness, we set the angle spread to be a bit higher. We can sort of, play with these settings. So I think that's looking pretty good now. It's not being too discriminatory. It's more kind of saying there's a small region where it's not really viable for trees to go, for these pine trees. Much more of the terrain is viable. So that's not going to remove too much of what we're masking there. And if I just play with this this angle, we can sort of change which slopes that's going to favor. So I quite like this, I think. So now I can go ahead and turn on mask by slope once more, mask by height once more. And you can see how by combining all of these different masking settings, you can really start to isolate sort of the regions that you want specific woodlands to cover or specific biomes. And I think I'm just going to make that mask by occlusion a little bit less aggressive. So there we go. We have plenty of room for these trees to be scattered. So if we have a look at our scatter, we can see that we're now getting a scatter that's a little bit more interesting and a little bit more sort of sitting on one slope or another. Let's just turn, actually, you know what, let's just run with it. You could compare that to what we had before, but I'm not going to bother. So I'm going to go ahead and hit save to disk. And now to get that in, quite simply, we can just hit reload geometry. And there we go. We now have our new scatter. So we have sort of these low-lying regions where there aren't any pine trees. We have some sparse pine trees up here, and you can see how they're sort of conforming to sort of interesting areas of the terrain. They're not really sticking onto the exposed areas or the really steep slopes there. So that's pretty nice. But what we're seeing, which I don't like, is that we're getting these pine trees in the scree field. So this is a place where there's going to be lots of falling rocks. So, it would be unlikely that trees would really be, there would be many trees occupying those regions. And similarly, we've got these paths that we crafted previously, and we've just got trees in the middle of our paths. So let's go ahead and try and deal with that. I'm going to jump back inside of Houdini once more. And this time, we're going to take a look at our second input, our ID input here. So we can go ahead and call this IDs. And so let's think about what we're trying to do. We're trying to essentially say trees cannot grow on these scree regions or on these roads, right? And we don't have the ability to just kind of mask the roads out with this mask by feature. And similarly, the scree mask is quite complex. So it would be hard for us to go and identify exactly the same regions that we did previously. We could, of course, pull in those masks from outside of the subnetwork, but that's going to make our network a little bit complicated and a little bit hard to follow. So what we're going to do instead is we're going to take advantage of the height field layer to, not the height field layer to ID, that's the wrong way around. Height field, and I actually need to write height field ID to layer, like so. And what we can do with this, very simply, is we can basically grab one of those layers and just extract the mask from it. And I want to grab, instead of trying to grab the, you could grab the cliffs, you could grab the scree, and then you could subtract that from this mask over here, and that would be totally fine. You could also do the same with the trails. But I think the way I'm going to do it is I'm just going to grab the grass there. I'm going to grab another one, grab grass 2 as well. And this time, instead of copying that into the mask layer, I'm actually going to not add it, I'm going to do a max operation. So now we have a combination of the grass 1 and grass 2 layer, which means it's excluding all of the roads and all of the very steep slopes and all of the regions where we have scree on the terrain. So what I can do is I can just put down a height field layer like so. After the height field visualize, we're going to wire in those new masks, and we're going to replace just the mask layer. Okay. And then we're going to wire the output into our height field mask by feature. Now, by default, the height field mask by feature is going to overwrite those masks. So we just need to go all the way to the top. And again, we need to hit, actually this time we need to hit multiply. And now we're going to see that we get a mask that takes into account those scree regions as well as all of those roads. So we shouldn't be getting a scatter of trees on our roads or on the scree. Go ahead and hit save to disk once more. And we can go ahead and hit reload geometry. And there we go. We now get a very beautiful sort of arrangement of trees that's never going to sort of impact the areas preserved for gameplay or spawn in regions that would be unrealistic. All right. So it's starting to look quite nice and intricate, but I think my forest is looking a little bit too, sparse. So what I'm going to do is, now that we're spawning many less points, as you can see here, I'm going to go to the height field scatter settings, and we're going to increase that number of scattering by a factor of 5. There you go, that's much higher. In fact, let's go by a factor of 10. So now we should be getting 10 times more trees. We can save that out, and we're going to go ahead and reload. And you can see how with this workflow, you have the full power of the Houdini context while you're working, so you can sort of see everything you're doing. And you also have the ability to very, very, very quickly import and see those modifications happening inside of Unreal. So yeah, really, really love this way of working with Houdini and Unreal. Now, I would say that I probably went a little bit too dense there, although let's have a little look. Yeah, definitely too dense. Although, you know, it might be realistic. It's, I think, not great for gameplay purposes, and it's also starting to impact my performance a little bit because all these trees are nanite trees. So we're getting quite some overdraw there. So now, instead of decreasing just the scatter density, which is just going to naively reduce the number of points, we're going to try and add a little bit more subtlety and a little bit more nuance. So we're going to say instead of just scattering less, we're going to keep scattering the same number of trees. But if trees are within a certain radius of each other, they're going to be kind of snapped together. So we're going to say 3 meters. And we're going to see now we get this quite nice, more even distribution than we get with the scatter, which has the added advantage of we're not going to get any points that are sort of intersecting with each other, which you might get from the scatter there. Okay, so that's not too bad. But we're going to do one more thing as well. Let's go and have a quick little look at our output there. And we can see that we're just kind of getting some random scaling of all of these trees right now. And that's not really what I want. I want to be able to sort of like control the scaling and thereby sort of determine which trees are the oldest in the woodland. And the way that I'm going to do that is I'm going to put down a little wrangle here, and we're going to plug it in before the fuse. It's getting a little bit complicated, but just bear with me. I'm going to say f at age, that means float age, is going to be equal to 1. So every tree has an age of 1. Okay, so now what we're going to do is we're going to do an attribute normalize float. I'm going to do this after the fuse. And this attribute normalize float is going to take age and it's going to convert it to p scale. Okay, and p scale is going to set the size of the trees. So basically, according to the age of the tree that gets determined, we're going to change the size of the trees. We can visualize that output there. If we have a little look, there you go. You can see that we're getting these different sizes. Right now, it's completely random. Okay. Now, I'm going to quickly check the height field scatter. And my guess is that it's going to be doing some sort of random scaling, even though I can't see any settings that say it's doing random scaling. So what I'm going to do is before the attribute normalize float there, we're also just going to delete the p-scale attribute. There we go. So we're making sure there's no scale that's being randomly assigned by the height field scatter. Have a look at our output once more. Okay, scatter, very nice. And actually, actually what I need to do is I need to put this out tree scatter here ahead of the Unreal instances. So basically for this preview, we're getting just the Houdini relevant attributes, not the Unreal attributes, because these attributes are just for Unreal. And actually, we can do the same there. So there we go. That's our Unreal section, and this is our Houdini line. Okay, so now inside that attribute normalized float, we're setting the scale. And we can see that everything has the same scale because we're not doing anything with that age attribute apart from creating it. Create age attrib. Okay, so the way that we're going to do this is going to be really simple. We're going to go to our fuse, and we're going to say attributes to snap. Okay, and we're going to do sum. So we're going to add all of the age attributes of the trees that get snapped. Okay, so this means that the areas that are densest in the scatter, thereby having more trees, they're going to get fused. We're going to end up with less trees. But if there were a lot of trees there in the first place, they're eventually getting fused and combined into one bigger tree. So in this way, we can create a kind of simple but effective way of giving the impression that some trees are sort of like older and in logical places within this woodland of pine trees. So let's go back and look at that output. And I'm just going to go ahead and actually make sure that I'm packing those. No, that's not going to work because then we won't get the color. So we're going to leave it as is. But we're going to go to that attribute normalize float. And then we're going to try and remap the output. So we're going to try and change the output scale there. Try 0.5. There we go. So basically this is now the range of scales that we're going to get on our trees. So if I set this to 1.5 and then leave that on 0.5, you can see that red tree there, which is at the rightmost end, therefore it being the oldest tree, is the oldest tree in that batch of woodland, followed by this kind of orange tree here, and a few other large trees there, which all kind of tend to occupy dense areas of woodland. So I quite like that. And you could sort of play around with it actually, and you could say, well, the trees in the densest area of woodland are going to be smaller because they get less light and less shade, in which case you could just remap that there. And that's going to give you the inverse, but you're probably going to want to change the profile so that you get, the kind of effect that you're looking for in terms of the relative distribution of scales. Yeah, that's actually quite an interesting one there. I quite like that, but yeah, I'm not sure I would want these really tiny trees on the outskirts. So let's go ahead and leave it on linear, and let's also make the overall range of scales slightly less because that's a bit too aggressive. Okay, so in one swoop, we've made the density slightly more appropriate for our goals, and we've also set the changed the scale of the trees to have something that's kind of guiding it. And if you want to make the forest less dense, you can just increase the snap distance there, which is also going to change the distribution of larger versus smaller trees. And this is probably slightly too regular, starting to look a bit like a plantation. So I think 6 meters or even 5 meters between each tree is a good amount. Now, if we just compare that to before, that's how dense it was previously. And that's what we're now looking at. So an orders of magnitude reduction in the number of trees. And you can see from a macro view, it's especially clear that the centers of the forest have these kind of lighter colors and ergo larger trees. So we kind of think of that as the old woodland. So now let's go ahead and hit save to disk once more. And once more, we're going to hit reload geometry. And that's starting to look a bit more manageable. Okay. So we've got our paths nice and clear of trees there, at least for the most part, and it's starting to feel quite nice. But I would say that still the distribution of these trees feels a little bit uniform, and there's one more thing we can do to sort of like spice this up even a little bit further. And we're not going to rely very heavily on what I'm about to do next, but you absolutely could do, and you could try and push it a bit further and see what kind of result you end up with. And I think I'm also going to reduce the sort of number of trees and creep them up the hills slightly further and away from that valley region. So back into Houdini, let's deal with that last part first of all. Go to the height field mask by feature, and we're just going to slide these trees back a bit. And you can see that now that we've got this set up, it's dead easy to sort of change the kind of like the overall placement and arrangement of these trees, but due to the way we've set it up, we're keeping those rules about where the trees are allowed to spawn in the kind of the micro scale quite nicely and sharply defined. Okay, so I'm trying to smooth it out. Yeah, no, definitely more on the slopes. So we're getting less pines overall. I'm quite happy with that arrangement for now. So then this last part that I was just talking about, which is how we can spice up that placement even further, is we're going to do it before the fuse there. We're going to play with a node called height field advect. Sorry, I have to actually type the full word, height field advect points. And I've got a whole video going into this node and all the ways that we used it on Project Pegasus. So I'd recommend checking that out if you want to look into how it's working and how it's set up. And what I'm going to do is, yeah, after the create age attribute before the fuse, it could actually be, maybe it makes more sense to do it here. There we go, just for sort of logical purposes. And then we're going to grab our in height field like so, and maybe wire it like this, just try and keep our graph a little bit more organized. So I'm going to go to our height field scatter, and what do we notice? Well, we notice that straight away something has changed. And the difference, what's happening here is, let's just increase the step distance, is these points are actually being slid along the slope according to its height or its gradient. We can go up or we can go down. And you can see this is going to be really nice sliding down for sort of doing rockfall type effects. But for the trees, we don't really want to use the height to guide where the trees go. We want to guide it by some other property. And as said before, we often have trees that favor sort of more or less occluded regions of the terrain. So that is areas where there's more occlusion means it's going to be damper, it's going to be potentially colder. So we're going to be looking at or actually maybe it's going to be warmer. It's going to be less wind. It's going to be less exposed in more occluded areas, but it's also going to collect more rainfall. So it's a very core component of how plants like to deal with terrains, with landscapes, is the level of occlusion they have. Or it's at least a nice shorthand for us to use as artists. So we're going to put down a new mask by feature there. And we're actually going to, we're going to wire it out from here because we have our visualize already set up. And this time we are going to replace all the previous masking we did. I'm going to create a mask by occlusion like so. And we could probably just leave it under the default settings. So let's just leave it on the default settings like so. And let's have a little look at what we can get out of the gate. If we go to our add vec points and decrease the number of steps, we've played with the step distance there. That's how far it can move in one step. And then the number of steps is, we're still using the height as our guide. So we just need to set that to mask. Okay. And if we put that on 0, we can see we've got our raw scatter. But as we drag up the steps, something interesting happens, which is these trees are sort of trying to collect in various areas of the terrain. And those areas are the areas which are currently, let's have a little look, the most exposed. So I think that this is interesting, but I'm going to try down as well. And we're going to have a look. So these now going to collect in areas that are less exposed, and it's quite interesting too. But I'm going to increase the step distance here because I want this to kind of function a little bit like seeds sort of like dispersing in a way and collecting. And if I increase the step distance, it's going to kind of give it a more of a rough kind of look there. So we can see it starts to pool in different regions of the terrain. And if I go to the mask by feature, I could sort of play around with the profile of this curve, and that's going to give us some slightly different results too. So I'm going to just play with this. So I just really want to just inject a little bit more pattern really to this scatter. So I think that's looking pretty good. It's creating nice little clumpings of trees there. Afterwards, it's going to go into the fuse, and essentially the main thing that this is doing is it's just determining the areas of dense woodland. So you can see we can define where that clumping starts to happen, and we can reduce the snap distance of the trees because more trees are going to be kind of in similar regions. Let's maybe go with 4 there. But there's one more problem, which is that now these trees have snuck back onto our roads. So the way we're going to deal with that, quite simple. We're going to use the height field ID to layer once more. We're going to pick the trails. I'm going to put down a height field mask blur. Okay. And yeah, I think 10's looking pretty good, but maybe I'll put down a height field mask expand as well. So we're just going to crank up the intensity of that road a little bit. Height field ID to layer. Oh yeah, I need to make sure this is copy. There we go. So it's just getting the roads. Mask blur. It's pretty good. So now we can copy the add vec points once more. And now we can roll these trees away from the roads. You can see how aggressive that was by default. So we're going to decrease the step distance there and decrease the number of steps. And then we're going to sort of slowly increase that there. And you can see the effect you get is that the trees sort of slide away from those roads. In fact, let's wire that into our network. And we can see that in action. So that's without. We get those trees on our roads, and then we sort of slide them away, leaving our roads nice and clear for walking around on. Okay. So that's basically it with the scattering. I'm just going to go ahead and save this to disk and reload that once more. And then I'm going to go ahead and do the scatters for the other tree species as well. And I just encourage you to go ahead and do that yourself too, and figure out how you can use the tools and approach that I've just shown you there to sort of create really nice and slightly more interesting scatters than you would get just by sort of naively scattering things on the terrain.